Hi, everybody. Today we're going to be talking about multiplying fractions together. And I think you're really going to like today's lesson quite a bit. It's a lot easier than working with decimals, and I think you'll agree with me on that once we're done with this lesson. So let's say, for example, we're going to multiply 5/8 times 2/3. What's nice about fractions is you just multiply the same way you always multiply, straight across. So when you're looking at a fraction, the top is called the numerator, and I'll write that down here. Gotta get myself a good color, the numerator. And the bottom number is called the denominator. I will be using these words quite a bit. Sorry, they're kind of big words, but at least they both end with "ater," so that makes it a little easier to remember. The numerator and the denominator. So I'm going to go ahead and multiply these together. And again, I just multiply the numerators, 5 times 2, that's the numbers in the top of the fractions. And that goes over the product of the denominators, 8 times 3. And so 5 times 2 is 10 over 8 times 3, which is 24. And this is the answer to this problem. Okay? Now, some of you might be noticing that this fraction, 10 over 24, we can simplify it. Both of these numbers are even. So if I divide these both by 2, then I would get 5 over 12. That has the same value as 10 over 24. And sometimes people say, well, the number's changed. How can it really have the same value? Well, when you're dividing by 2 in the numerator and you're dividing the denominator by 2, you're actually dividing by 2 halves. And 2 halves is exactly the same thing as 1 whole. Anytime you divide something by 1, doesn't its value stay the same? We can call that the identity property for division, in fact. So we're taking 10 over 24 and we're dividing it by 2 halves. So it retains the same value. It's just in simplest terms now. We have 5 over 12. All right, let's look at another example here. We have 3/5 times 1/4. Again, I can multiply straight across, starting with the numerators, 3 times 1, over the denominators, 5 times 4. So I'll go ahead and multiply 3 times 1 is easy, that's 3. Over 5 times 4, that's also easy, that's 20. I like this one better than the last one because 3 over 20 is already fully simplified. I'm going to show you another way that we can do this so we don't have to do our simplifying at the end, but I'll show you that in a little bit, okay? All right, let's look at another one. We have 5/6 times 4/5. Okay? So again, I multiply my numerators together. 5 times 4 is 20. And I put that over my product here when I take 6 times 5. 6 times 5 is 30. Now, I did not show the middle step where I have 5 times 4 over 6 times 5. I probably should have shown it, but I think most of you are just going to go ahead and do this because it's quicker, it's easier, and it works fine. Okay, now I can simplify this. Hopefully you notice both these numbers are ending in zeros, which means they are both divisible by 10. And so I'm going to divide both of these by 10. What I'm literally doing is dividing by 10/10. Okay? Which means I'm dividing by 1 whole, which isn't going to change its value. Okay? But it does get it in simpler terms. 20 divided by 10 is 2 over 30 divided by 10, which is 3. So my answer in simplest terms is 2/3. By the way, some people, rather than showing this step right here, when they see 20 over 30, they'll just say, you know what, if I divide them both by 10, those zeros at the end will cancel out and I'll just have 2/3. You can do that too, but I really do like seeing this right here so I can see exactly what you did. You divided by 10 both in the top and the bottom of the fraction. All right, one more here. 2/3 times 4/5. Now again, I can just multiply straight across. 2 times 4, multiplying the numerators together, that's 8. Over 3 times 5, which is 15. And that is my final answer. Oh, Mr. Wyatt, it really can't be this easy, can it? Actually, yes, it is. It really is this easy. And what's nice here is this is fully simplified. We have nothing more to do there. All right, so I promised I would show you another way that we can do our simplifying. So I'm going to go ahead and erase my work for this problem. And back on the prior page, I'll erase my work for this problem. Because those were the two examples where we had to do some simplifying at the end after we had multiplied them together. Okay, I'm going to show you how you can simplify these ahead of time. All right, when I see 5/8 times 2/3, instead of just multiplying them together right away, why don't I look to see if I can do any simplifying? And the rule here is if I can spot a number in the numerator and in the denominator that can both be divided by the same amount, I can go ahead and do that. So I'm looking in the numerator here. I see a 2 right here. See this 2? And in this other fraction in the denominator, I see an 8. Those are both even numbers. They are both divisible by 2. In fact, 2 divided by 2 is 1. And here, 8 divided by 2 is 4. All right. Now, if I look to see if there is anything else, I do have a 5 up here, but I can't divide it by the same thing as any of the factors of 4 or of 3 because they don't share any common factors other than 1, and dividing by 1 isn't going to simplify anything at all. So I'll just multiply now. Numerators, 5 times 1, that's 5, over 4 times 3, which is 12. That is my final answer. It is fully simplified. Okay? Now, when we did it the other way, we just multiplied 5 times 2, 10, over 8 times 3, 24. And then we simplified it. And we ended up with this same result, 5 over 12. Um, on this example, it's just as easy to simplify at the end as it is to do your simplifying at the start. But there are a lot of problems where it's a lot easier to do your simplifying at the front end while the numbers are still smaller and more vulnerable, okay? So keep that in mind. In this example here, 5/6 times 4/5, I can again do the same thing. Look to see if I have any numbers that can be simplified. And I notice right away I have a 5 here in the numerator and a 5 here in the denominator. Those are both divisible by 5. 5 divided by 5 is 1. 5 divided by 5 is 1. So actually, not only did they simplify, they actually canceled out. When you're simplifying numbers and they happen to be the same number, we call that canceling because both of them are gone and all we have left are ones here. Okay? So yeah, they say, yeah, you simplified me, but we're really cool. You have to say you canceled us because we gone. I mean, they're all the way down to having just one for a value after you divide them both by 5. And now I'm also noticing there is a 4 here and a 6 here. They are both even. I can divide them both by 2. All right, so 4 divided by 2 is 2. 6 divided by 2 is 3. Okay, so when I multiply now, 1 times 2 is 2 over 3 times 1, which is 3. This is my final answer, 2/3. Okay, now you might be thinking, well, the other way was easier. I mean, 20 over 30, I was able to simplify that very easily. That's true. It actually was easier the other way on this particular problem. But most of the time, it's going to be easier to do your simplifying at the front end here at the beginning of the process. One more thing I want to mention, because a lot of people don't realize this. What if I had, for example, and I'm just making this problem up here, 4/8 times 5/9. Can I do any simplifying here before I multiply these together? And some people think, well, I thought I can only simplify if they're, diagonal from each other. Actually, we have a 4 here and an 8 here. And I can simplify those even though one is right above the other. It's okay. The only rule is one has to be in a numerator and the other has to be in a denominator. 4 and 8, I can divide them both by 4, and I get 1 here, and 8 divided by 4 is 2 here. And so now I have 1 times 5 is 5 over 2 times 9, which is 18. That's my final answer. Actually, when you're simplifying and they both happen to be in the same fraction, you're actually just simplifying that fraction. So yes, absolutely, you can do that. They do not have to be diagonal from each other, okay? You can do that when they're one right above the other. All right, one last example. It's a word problem. You are making lasagna. Ooh, lasagna. And you need 5/6 cup of mozzarella cheese for 2 batches lasagna. This means that you need half of the mozzarella in each batch. How much mozzarella do you need for each batch? Okay, so each batch is using half of the cheese. So I'm going to write that down. If I need to figure out how much cheese is in one batch, it's going to be 1/2 of our total amount of cheese, which is 5/6 cup. All right, in math, when you see the word of, not always, but almost always, it means we're multiplying. Okay, so when I'm trying to find half of 5/6, I'm going to take 1/2 and I'm going to multiply by 5/6. Okay, so before I multiply these together, let's see if we can do any simplifying. Is there anything I can simplify here? Hmm, you might be thinking, well, what about the 2 and the 6? They're both divisible by 2. The problem is they're both in the denominators, and we do need one in the numerator, one in the denominator to simplify. So there isn't anything that I can simplify. All I can do is multiply. 1 times 5 is 5 over 2 times 6, which is 12. So 5/12 of a cup of mozzarella cheese goes in each batch. Okay? Now I got to be honest with you. I don't think it's possible to put too much cheese in your lasagna. So if you want to use more cheese than 5/12 of a cup in your lasagna, well, just be sure to invite me over because I want some of your lasagna. Okay? All right. Have a nice day, everybody.